To this point, we've seen some examples of equations that look like this. The values of a are given, and linear functions of the x's are related to the y's. In the diet problem that we described, the value of x was given, and the task was to solve for the y's. Well, that's very easy. Even in this general case, it would just be two nested for loops in MATLAB. Allocate y to be a zeros vector of the appropriate dimension, and then loop over that. Each component of y is a summation of m terms, and that can be implemented with a for loop, just accumulating the sum, and then two ends. In the truss structure problem, it was different. The value of the y's were given, and the task was to solve for the x's. That doesn't look quite as easy. It's not clear how to just write a for loop to solve for the x's. And more questions arise. Are there any solutions? And if there are solutions, how many? Is there one solution or many solutions? Loosely, we'll call these the forward problem and the inverse problem. For the next set of slides, we're going to focus only on understanding the inverse problem, since the forward problem is fairly straightforward. There's a bunch of inverse problems that can be solved by inspection. Here's the first one. One equation, one unknown. The problem data is a11 and y1, and this is the system of equations. As mentioned, it's one equation, one unknown. There's really three cases to the solution. If a11 is not 0, then there's one and only one solution. We'll say that as there exists a unique solution, and the solution is just as you'd expect. Divide both sides by a11. Another case is that a11 is equal to 0 and y1 is equal to 0. Well, then there's an infinite number of solutions. Any x1 is a solution. And finally, the case when a11 equals 0 and y1 isn't equal to 0, and then there are clearly no solutions.